Projectile is the path discovered by a projectile and it is parabolic in shape. And here we consider a projectile which is projected with the initial velocity u, and the initial velocity is resolved into two components, the vertical u sin theta and the horizontal u cos theta. The vertical component keeps the body vertically upwards, whereas the horizontal component keeps the body in the horizontal direction. And in order to explain about the character of the projectile, let us imagine a point. When the projectile is reached here, it has a vertical displacement, that is y, and a horizontal displacement, that is x. We can measure this vertical displacement using the kinematic equation S equals ut plus half at square. Here we measure the vertical displacement. So the displacement is in the vertical direction and the initial velocity also in the vertical direction, that is uy, and the acceleration is also in the vertical direction, that is ay. And the displacement in the vertical direction, that is sy, that is a vertical displacement, that is y. And the initial velocity in the vertical direction, that is u sin theta, that is uy is equal to u sin theta. And the acceleration in the vertical direction, that is acceleration due to gravity, that is ay is equal to minus e. Substitute these values in this equation. Y is equal to u sin theta t plus half minus g t square, that is y is equal to u sin theta t minus half gt square. Put in equation number 1. When we consider the horizontal displacement of the body, there is no acceleration in that direction because the horizontal velocity u cos theta is constant, and we can also measure the horizontal displacement using the relation is equal to ut plus half at square. Here we measure the horizontal displacement, that is xx, and the velocity also in the horizontal direction, that is ux, and acceleration also in the horizontal direction, that is ax. And the horizontal displacement, the x is, that is x, and the velocity in the horizontal direction ux is equal to u cos theta, and the acceleration in the horizontal direction ax is equal to 0. Therefore, the displacement x is equal to u cos theta t, or t is equal to x by u cos theta. Substitute this value in this equation number 1, that is u sin theta into x by u cos theta minus half g into s square by u square cos square theta. To x tan theta minus 1 by 2 g by u square cos square theta x square. Tan theta is constant because theta is constant, g constant, u is constant because it is initial velocity, and cos square theta is constant because theta is constant. So this term can be taken as constant, and this tan theta can also be taken as constant, and take tan theta as a and half g by u square cos square theta as b. Then the equation becomes ax minus bx square. y is equal to ax minus bx square is the general equation of parabola. That means the trajectory is parabolic in shape. The horizontal range is the horizontal distance attained by the body, and we will get same horizontal range for two angles of projection. We know that the expression for horizontal range, that is r is equal to u square sine 2 theta by g, which is again equal to u square sine 190 minus 2 theta by g, which is again equal to u square sine 2 into 90 minus theta by g. That is u square sine 2 theta by g is equal to u square sine 2 into 90 minus theta by g. Compare these two equations. Here u square sine 2 theta by g, that is 2 of theta, and here u square sine 2 of 90 minus theta. Compare these two equations. Compare these two equations. Sine 2 theta is equal to sine 2 into 90 minus theta. That is theta is equal to 90 minus theta. Which means that for two angles of projection, we will get same horizontal range. As the projectile begins to move, it is suffered by three types of velocities. The vertical component u sin theta, the horizontal component u cos theta, and a vertically downward velocity due to the force of gravity which has a magnitude gt. Suppose the body is at the position P, and there is a vertical component that is u sin theta, and a horizontal component that is u cos theta, and a downward velocity due to the force of gravity that is gt. That is, the body suffered these three velocities. So the resultant velocity v is equal to root of u sin theta minus gt the whole square plus u square cos square theta. That is again equal to root of u square sin square theta plus g square t square minus 2u sin theta gt plus u square cos square theta. That is again equal to root of u square sin square theta plus u square cos square theta plus g square t square minus 2u sin theta gt. Here sin square theta cos square theta 1. Therefore, the final equation is equal to u square plus g square t square minus 2u sin theta gt. This is the expression for the resultant velocity of the projectile. The velocity at the end means the velocity when the projectile completes its journey. Here, when the projectile reaches the ground surface, it has a velocity along the x direction, that is the horizontal component, and a velocity the vertical direction due to the force of gravity. That means the projectile strikes on the ground with a resultant velocity v, and that resultant velocity v is equal to root of Vx square plus Vy square. For an oblique projectile, we know that the vertical velocity, that is vertical component of velocity, Vy is equal to u sine theta minus gt, where t is the time taken. And when the projectile completes its motion, the time taken t takens to the capital T, time of flight, that is Vy is equal to u sine theta minus g into capital T. That is again u sine theta minus g into, we know the capital T, the time of flight, that is equal to 2u sine theta by g. G cancelled. That is equal to u sine theta minus 2u sine theta, that means minus u sine theta. That is the vertical component Vy is equal to minus u sine theta. Therefore, the resultant velocity V is equal to root of Vx, that is horizontal component, that is u square cos square theta, plus Vy, that is the vertical component, minus u sine theta, the whole square. That is equal to r root of u square cos square theta plus u square sine square theta, that is equal to root of u square into cos square theta plus sine square theta, that is equal to root of u square, that is equal to u. That is the velocity at the end of the projectile is equal to the velocity at the beginning. Velocity at the end of the projectile is same as the velocity at the beginning of the projectile in magnitude. The projectile motion obeys the conservation of energy. When the body is projected at the time of projection, the body has an initial velocity u and the body is on the ground surface. Therefore, the total energy is equal to potential energy plus kinetic energy. The body is on the ground surface, so potential energy is equal to 0. That is 0 plus half m u square. The body only the kinetic energy. That is the total energy is equal to half m u square. And when the body is reached the maximum height, it has no vertical component of velocity, the u sine theta turns to 0, but the body has a horizontal component, that is u cos theta, and the body is at a height from the ground surface. So when the projectile is reached at the maximum height, it has both potential energy and kinetic energy. So at the maximum height, total energy is equal to potential energy plus kinetic energy. Here the potential energy, that is mgh plus half m u cos theta the whole square, that is equal to mg, we know h is equal to u square sine square theta by 2g, u square sine square theta by 2g plus half m u square cos square theta, that is equal to 1 by 2 m u square sine square theta plus 1 by 2 m u square cos square theta, that is equal to 1 by 2 m u square into sine square theta plus cos square theta, that is equal to half m u square. That is the total energy at the maximum height is half m u square. And when the body is reached the destination, that is at the end of the projectile, the velocity is v and the body is on the ground surface. Therefore, total energy, here also potential energy plus kinetic energy. Since the body is on the ground surface, it has no potential energy. Therefore, total energy is equal to 0 plus kinetic energy, that is equal to half mv square. That is equal to half mv square And we know that the velocity of projection is same as the velocity at the end of the projectile. Therefore, it is equal to half m u square. That means the total energy at the end, the total energy at the maximum height, and the total energy at the beginning of the projectile, all these energies are same. So the projectile is in accordance with the conservation of energy. That is all.